Hi, this is Prieto and this is my extra credit lecture video. I chose to attend the Higgs boson lecture presented by Dr. Howard Gordon. Now, what exactly is this Higgs boson? Well, I found myself asking the same question before I attended the lecture. To start off, a quick introduction of the hierarchy of particles. First, you go from matter to molecules to atoms to nucleus to protons to smaller subatomic particles, which consists of quarks, leptons, and many other subatomic particles. And as you know that we've learned, there are four forces of nature: strong force, electromagnetic force, gravitational force, and weak force. Those four forces act on all types of matter, but quarks are only affected by strong force, weak force, and electromagnetic forces, while leptons are affected by weak and electromagnetic forces. Now, all fields have particles associated with them, and that is the idea behind the Higgs boson. As particles go through a Higgs field, they acquire more mass. And the Higgs boson explains why particles such as electrons and other types of elementary particles have mass. And now, how do they test for this Higgs boson? Well, this experiment is called the ALICE experiment. They use the Large Hadron Collider in Switzerland. The Large Hadron Collider is the world's largest and highest energy particle accelerator. It is considered to be one of the greatest engineering milestones in the history of mankind. As the name implies, it is very large, at 27 kilometers in circumference, and this collider creates 10 to the 9th power interactions per second. That's 25 interactions every 25 nanoseconds. And they use energy to create mass using the equation E equals mc squared. Now, in order to prove that this Higgs boson exists, the benchmark that they set is to have a mass of over 114 GeVs. A GeV is a giga electron volt, which is the equivalent of 1 billion electron volts, which is so it's a very small amount of energy. Now, the new particle that they found during the ALICE experiment was found at 126 GeVs, and that is what they believe is the Higgs boson particle. Well, now how does this large experiment relate to us here in Physics 1 at Georgia Tech? Well, this experiment uses basic principles of physics that we learned. The conservation of energy, for example, is used here when the particles are collided. When they collide, they explode. They basically explode into billions of smaller atomic particles, and through that, the energy is still conserved at all times. Same exact concept with the conservation of momentum, where you can add up the momentum of all the individual particles, and it would be the same as before the collision occurred with the protons that collided. Now, although quantum mechanics is extremely complicated, it all boils down to the simple principles that we have learned and practiced here at Georgia Tech in our physics class. And that's it for this video. Thanks for watching. I hope you guys enjoyed it. Have a good day.